This is all mucosal layer. So they're showing it to you, mucosal layer, that's where the villus is, okay? And then underneath of that is muscularis layer, 2 layers of muscle, circular muscle, longitudinal muscle. And then outside of the layer, very outside is serosa layer. That's submucosa, I'm sorry, I missed submucosa. You have to know, for the lab, I do not expect you to know serosa layer, but I will expect you to know submucosa, mucosa, going from inside. It goes from this side to that side. Mucosa, submucosa is white, and then muscularis layer, which is circular muscle and longitudinal muscle. I hope I'm making some sense. Okay, yes?
And we have to do that on that model for everyone? There's submucosa and the mucosa layer?
Yes, I will go over it in a minute. Okay, well, let me get the idea. It's bothering me. Here is the mucosa. Here is in the lab. This is villus, and here is simple columnar epithelial tissue. These are goblet cells. This is a muscularis layer, and the submucosa is a blue area. All of the blue area is submucosa. All of this is muscularis layer, and here is simple columnar epithelial tissue. You can see some brush border here a little bit, and these are goblet cells, and capillaries here. Okay, same thing. It does not show you guys. I don't know why it does not label. I should label it later on. But okay, so let's go over this model, and I'll go over that model again. So here on this model, you guys, can I borrow you again your space a little bit? I hope I'm in there, William. If I'm not in there, I'll go jump off the Golden Gate Bridge. It's just 1 hour, 1.5 hour drive. It's not much. 1.5 hour, park the car there and jump. I hope it's in there. Oh, I'm sorry. I ran my mouth. And yes, in there. The model is in there.
Some of the bottom isn't in there.
The bottom is not there?
No.
We don't need the bottom.
Okay.
Just anus.
Right.
Okay, so food goes from mouth to trachea. This is your esophagus, stomach. In the stomach, you have 3 layers of muscles. In the lab, on the slides, make sure you see them. Oblique, circular, longitudinal. Okay, here in the esophagus, you have 2 layers of muscles. Circular, longitudinal. Okay. Then there is between esophagus and stomach, there is a sphincter here. There is a whole bunch of muscles they can shut. When you eat, when food goes in the stomach, they shut. And that's called cardiac sphincter. That's why when you get a heartburn, because food is going back from stomach into your esophagus. So there is a sphincter here, supposed to shut when you swallow food, because stomach is very acidic, right? pH of stomach is 2. You put your finger in a pH solution of 2 and you take your finger out, there's nothing left but bones. That's how strong it is. Okay, so what happens, the food in here get mixed up with the acid of the stomach and it cannot go up. So that sphincter shuts. It's called cardiac sphincter. And then food from here, oh, you see these folds? It's in your lab manual. These folds are called rugae of the stomach. You have them also in the vagina. So when you eat food, these folds become straight. This is probably an empty stomach. It has all of these rugae. Okay? So these folds, they become straight when stomach is full. Then from the stomach, food goes, there is another sphincter between duodenum, right here is duodenum, and the stomach. And that's called pyloric sphincter. Okay? So here is the liver, here is the gallbladder, and here is the pancreas. Right here is pancreas, you guys cannot see. Okay, here is the liver, gallbladder, pancreas. Pancreas releases this juice to the duodenum to neutralize the acid that is going from the stomach to the duodenum. And everything has to be back to normal again, to back to close to pH of 7. Duodenum 7, esophagus 7, pH, close. Okay, so neutralize all of that food that is coming from stomach, goes to the duodenum. And then in the duodenum goes to jejunum, ileum, and then this is large intestine, ascending. The transverse is missing in this model, and descending, and then out through anus, rectal anus. Okay, so there's other structures here I don't want to talk about. But gallbladder, the things that we are concerned for rest of semester, that's what I emphasize on. Because we will talk about parasites that they lodge themselves right here, later on. So this is gallbladder, and then there is, the liver makes bile. Bile breaks down soap. It's a biological soap, does not make soap. It's called biological soap, which breaks down fat molecules. So liver makes bile, and that bile goes through hepatic duct. And then the gallbladder is called cystic duct. There's a duct right here, it's called cystic duct. And they all come, the one from liver and from gallbladder, the bile goes to common hepatic duct, which is drawn in here. And that is dumped right here, and that is dumped into duodenum as well. So there are 3 ducts here I'd like you to know. One of them is hepatic duct. The other one is cystic duct from gallbladder. Gallbladder stores bile. People remove the gallbladder and they're fine. All it does is store bile. And then liver makes bile. Gallbladder stores it. And then cystic duct, and then common bile duct, which dumps the material, dumps the bile into the duodenum. Okay, I think I mentioned everything in this model that I wanted to mention. On this model, you guys, if you look at this, this is all mucosa layer, and this would be submucosa layer right here, and then this is muscularis layer. Muscularis layer, submucosa, and mucosa.
We're required to know that as well for the test?
Right, yes, for lab practical, yes. And then what happens in this model, you have the lymph nodes right here for fighting infections. The food you eat is full of bacteria. Oh, Amir, really? Yeah. Don't worry about it. These guys are there. You fight them all. Okay. So here's the lymph node. And then there is on this model, these are called duodenal glands. On this model, this is duodenal gland right here in the submucosal layer again. Duodenal gland and lymph nodes are in submucosal layer. And the muscularis layer, this is sacral muscle, this is longitudinal muscle. You can see it like this, sacral muscle, the way it is set up in your slides is like this. Sacral muscles run this way and longitudinal muscles are like that. This is the cut you will see in your slides. Of course, you will see it like this. Right? On the muscle layer, you will see it like that. Okay, I went over everything in here. Oh, lacteal is where when large fat molecules are absorbed and they go into your lymphatic system. Large fat molecules, and it's dumped near the heart. Okay, so that's the model of small intestine. I talked about all of the models. Okay, so here is the passage of food from salivary glands, of course. Oh, there are a few gland structures, organs in the body. They refer to them as accessory organs of digestive system. Okay, what they are? Accessory is like tie for men is accessory. For women, scarf is accessory. They don't need it. I don't need a tie, right? Just the first day to scare you a little bit. None of you got scared. You're still coming back. That's okay. That's it. I don't mind. I thought of next year, I'll put 2 horns and a tail. And that's for sure you all run away. Okay, but anyhow, accessory structures, accessory organs, it means, that does not mean our body does not need them. We do need them, but it means food does not pass through them. That's what accessory organs mean in the digestive system. I'm just talking about digestive system. I haven't gone anywhere else. I'm still in digestive system. So accessory organ are your salivary glands. Food does not pass through them. Okay? Then liver. Liver is part of digestive system. What happens during lab practical exam, I put liver slide in there, I say what system, and a lot of you write down, you're all over, I don't know.
Endocrine?
No, it does no. They do not classify it in endocrine system.
It's
They
digestive
classify
system.
it in digestive system. Yes. Immune system, you can write it down. Somebody, they do help with endocrine. They do help with immune system. They do a lot. Liver does a lot. But scientists, they like to put it in digestive system. Food does not pass through it. Gallbladder is the other one. Pancreas is the other one. These are all accessory organs. Pancreas, it could be digestive system or it could be endocrine system. During lab practical exam if you want to write it. So pancreas, gallbladder, liver, salivary glands, those are four accessory organs. Four accessory organs of digestive system. So what happens here, you guys? You have the salivary glands, and then stomach, of course, food passes through. Esophagus goes to the stomach, and from stomach goes to liver, and gallbladder, of course, is labeled here, and then pancreas and small intestine. So what is it? Amylase. Okay, this is what I want you to know, please. Your saliva has the enzyme amylase, and bicarbonate. I'm not too crazy about that one. My main focus on this slide, guys, is the enzymes. Amylase. It breaks down large fat, large carbohydrate molecule like starch. You know that based on your prefix suffix. Gastric juice, it has pepsinogen. It breaks down what? Protein molecule. It's one of the few enzymes that does not have ACE at the end. In Bio 1, you learn ASE at the end. It means enzyme. This is one of the very first few enzymes was discovered, and they didn't call it ACE at the end. Right? You all know what I'm talking about. So they call it pepsinogen. It breaks down pepsin. And renin, of course, is another enzyme and in ruminant animals. But again, hydrochloric acid, you already know that. Bile salts, pigment, cholesterol, that's bile. It's a biological soap. It's not an enzyme. It breaks down large fat molecules. Now, in pancreatic juice, you have trypsin, which is another molecule that breaks, another enzyme that breaks down protein. Chymotrypsin, carboxypeptidase, lipase, amylase, you all know what they break down. Lipase, what does that one break down? Lipids, carboxypeptidase, what do they break down? Peptide molecules, when you have 3 or 4 amino acids, small chain of amino acids attached together, it's called peptide. And then when you get to the brush border, right here, these are the enzymes I would like you to know. That was the lab question. When you get to the brush border, right here, okay, of the villus, right here, I showed it to you. I wrote it on the board, microvilli, brush border. Okay, these are the enzymes that you should know. And let's go over them quickly. Aminopeptidase, it breaks down what? Yeah, it breaks down the peptide bond between amino acids. Maltase breaks down what? Biology 1. Maltose. Lactase breaks down what? Lactose, which is found in what? Milk. Some of you do not make lactase, so you cannot eat dairy products. Am I right? They call it lactose intolerant. Okay, sucrase breaks down what? Sucrose is found in what?
Table sugar.
Sugar. The real sugar, not those fake sugar. The real sugar that came from Hawaii, the cane sugar. Hawaii was main producer of cane sugar, but nowadays I don't think they're number one anymore in the United States.
They still
Anyhow, yeah, they still make it. Alkaline phosphatase, I'm not too crazy about it. Nucleotidase, yes, I'm not too crazy about it. And nucleosidase, I'm not too crazy about these. But these are the ones, and plus you can find lipase and protease in the brush border as well. Okay, normally. Decreased bile secretion, secretin, and feedback. Again, there's not much here that I can talk about it, but I don't want to because just time is one of them. But if they've done a lot of research on gastrin. People who want to lose weight, they can, they do stuff with gastrin and so on and so forth, filling of satiety, chylomicron, there's a lot in the air. But anyhow, maybe two reasons. Maybe I do know a lot about this, I don't want to talk about it, or maybe there's too much information. But I'm not worried about that side. Okay, I'm not worried about that side. Liver, definitely. You should know the functions of liver. Without liver, you cannot live. Okay, so liver functions, storehouse for glycogen. Of course, after you eat breakfast, you eat lunch. A lot of glucose molecules, glycogen is glucose molecules attached together, are stored in your liver. And by this time, if you haven't had lunch, right now glycogen is being broken down. They're being broken down right now. Produce proteins, yes. Detoxify protein waste, yes. So liver. You remember what did filter the plasma portion of your blood? Kidney, right? What does filter the actual blood, the solid portion of your blood? Liver. So every Saturday night, Sunday night, maybe sometime during the week, you drink your wine or your, beer or your Johnny Walker. Say, this one is for Amir. Highly condemn that, because there were some studies, they came out, and now I think they abandoned that. I'm not following you up anymore. A few years back, 4 or 5 years ago, maybe 10 years ago, they said a glass of wine a day is good for you, it reduces your heart problems, heart, so on and so forth. And I kept saying that in my lectures, they're being recorded, they're online. I said, don't listen to that. They're just after bucks. They say that it's good for your heart, but they don't think about liver. It will, even though a small amount over a long period of time, it will ruin your liver. And nowadays they came up, I think recently, somebody told me that. They say, no, don't do that anymore. I drank wine for 30 years, now you tell me don't? Now I have cirrhosis in my liver? Now you say don't? What kind of person are you? Well, you didn't listen to Amir. That's what happened. So anyhow, it detoxifies. And when I was a kid, I still gotta go question my parents. When I was a kid, they fed us liver. They cut up sheep, whatever. Not for trade, for obvious reasons. But they gave us liver, and now I do not do that to my kids. I do not feed them liver of sheep, cow, or whatever animal you have, or chicken, because it's full of toxic material. Oh, it's cooked and forget it. Still the toxic material is in there. It's been cooked. It's organic and we forget it. Still toxic material is in there. I don't know what. Destroys worn out red blood cells. That's right. That's why you see your poop brown. If your poop is not brown, Houston, we got problem. Apollo 13. Go ahead and watch it. So you know what I'm talking about. So if your poop is not brown, it's because of your red blood cells inside of your body for 120 days. After 120 days, you have new red blood cells. Your skin, 2 to 3 weeks. The cells from your mouth to your anus, 2 to 3 days. They break down, new cells come out. They break down, new cells come out. Same as your red blood cell. Symptom, is that me again? And it's my wife say, Amir, I love you. She always calls me. I said, have you seen that movie that, you know, the person forgets next day, the woman forgets next day? That's my wife. She calls every day and says, Amir, I love you. I'm good, I guess. Okay. Center for Metabolism of Fat, Amino Acids, and Carbohydrates. Of course, I didn't talk about it. If you take a nutrition class, they will talk about this a little bit. And then makes ammonia, and the kidney turns this ammonia to urea, yes. But what happens, your liver, when you have protein molecule, when you eat in your diet, you eat protein, what happens, some of those amino acids break down. When they break them down, the liver breaks them down, and then, you know, amino acids have the ammonia group and the central carbon and carboxyl group, bio-1. Again, I'm refreshing your memories from bio-1. And that ammonia is toxic for body. You cannot have it in your body. So liver converts it to urea, and then urea is less toxic to your body. And then that urea is shipped to kidney, and kidney will get rid of it. Okay, so you see the importance of liver, and the only way you can damage your liver is alcohol. Not by eating fatty food, not by eating, I don't know, the only real toxic material, even though for a long time. One glass of wine every day for a long time, they didn't listen to me. Is that right? They didn't listen to me. But anyway, so let's go over. I like you to know those. That's very, 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 very important to me. Oh, this one. This one you learned in Biology 1. I'm refreshing your memory. Don't say, no, Dr. McCready didn't talk about it. Yes, she did. But let's go over it quickly because it's all refreshing. And I'm looking at a different angle than Biology 1. What happened in Bio 1? Forget about these 2 or 3 terms. I put them in there if you need to know. But if you eat carbohydrates, what happens? They break down to glucose. You ate mashed potato for breakfast. Right now, those mashed potatoes are glucose in your body. Glucose breaks down to pyruvate. You know that. Pyruvate has 3 carbons. So you put 2 pyruvates together, it's a 2-way street. It's like you love somebody, the other person loves you. Is that right? They keep calling you. So it's a 2-way street. Then pyruvate becomes acetyl-CoA. It's a 1-way street. Acetyl-CoA cannot become pyruvate. Do you follow the arrows? Because you have to draw this for me next week. So follow it. So pyruvate, you learn in Biology 1, can become acetyl-CoA. Acetyl-CoA cannot become pyruvate. Acetyl-CoA goes through Krebs cycle. You learn that, Bio 1. And Krebs cycle electron transport chain gives you 34 ATP. You have energy to conquer the world. You ace zoology, right? That's the pathway for carbohydrates. What if you have egg for breakfast? What happens? Or a steak for breakfast? So that the egg steak have amino acids. They break down to some amino acids. Those amino acids can become pyruvate. Pyruvate have to attach to another amino group to become amino acid. Am I making some sense a little bit? That process is called transamination. It means you take your body, not you. Your body takes pyruvate automatically done for you and add amino group to it. It makes some of the amino acids. You open up a biochemistry textbook, it tells you what amino acids. Out of 20 amino acids, it tells you which one. Okay, and it also tells you which amino acid can break down to pyruvate by process of deamination. You strip off that amino group and you have the carbons, and those carbons become pyruvate. So it's a 2-way street between some amino acids and pyruvate. Do you follow what I'm talking about? This one, some amino acids become acetyl-CoA. No amino acid is made from acetyl-CoA. It's a 1-way street. Am I following myself? Okay. Then some amino acids become intermediate of Krebs cycle. You know intermediate of Krebs cycle, citrate, isocitrate, alpha-ketoglutarate, all of those goodies you learn in Biology 1. Okay, so we can become those intermediates of Krebs cycle, some amino acids. Okay, and intermediates of Krebs cycle, some of them become some of the amino acids. I hope I'm making some sense so far. Then what happens in your breakfast, if you had butter or you had avocado, triglyceride is most of fat in your diet. Most of the fat in your diet is triglyceride. Then triglyceride can break down to glycerol and fatty acid. Fatty acid can break down to 2 carbon fragments and become acetyl-CoA. If you're fasting, what happens eventually over a long period of time, your body attacks your fat cells right here. So it goes, the 2 carbon fragments become acetyl-CoA. Acetyl-CoA goes through the electron transport chain, gives you ATP so you can do function. I hope I'm making some sense. Now what happens, this question, you had it this morning, Fred or Adam or whatever was his name, he does not eat carbohydrates at all. All he eats is protein and fat, and he still does not lose his weight because he doesn't exercise. See, you don't exercise, you don't do this much. Your body does it, but if you don't exercise, it doesn't, electron transport chain does not affect too much. Okay. So what happens if he does not eat carbohydrates, but he eats a lot of protein? And what happens is amino acids, they can become pyruvate, pyruvate become glycerol, and glycerol can become triglyceride. Now the glycerol here, 3 fatty acids attached here, and they stored in the body fat. Or become amino acids, can become acetyl-CoA, they lose their CoA, become fatty acids, fragments become fatty acids, look at the arrow, and then eventually you store in fat cells of the body. That's why he does not lose weight. If he needs to lose weight, he needs to exercise. Okay, so that's pretty much the pathway. Yes, ma'am?
So triglycerides are the stored version of fat.
Right. Triglycerides are stored in your fat cells, adipocytes. You know the term for it in this class. Adipocytes. Any other questions before I go? Okay, so we did talk about that one too. Endocrine system is the next one. In endocrine system, you guys, you have 2. It's not written anywhere. Maybe it comes up, but while it's fresh in my memory, I should mention it. Endocrine system is pretty much a study of glands and hormones of your body. It's called endocrine system. And then we do have 2. Your endocrine system is made up of exocrine and endocrine system. Endocrine system, it releases its hormone or products into the blood. As I said, everybody on campus talks about dance, or they're playing basketball, or they talk about John McCain or Donald Trump. Here we talk about blood, poop, urine. That's nasty. But anyway, Nick said is that what? Triumph. You said something the other day. But anyway, so endocrine system is made up of endocrine and exocrine. Exocrine, whatever material they release, it goes to a duct. Can you give me an example we studied today? Exocrine assadi, you remember that in your pancreas in the lab? Those of you who looked at the slides ahead, it's called exocrine assadi. The exocrine assadi, they are in your pancreas, and by a duct, they're connected to, they release their whatever material they release, it goes into duodenum. The ducts end up into duodenum, the pancreas. So you do have your sebaceous gland in your skin. It's an exocrine. They release the fat and material into a duct. End up in and then anyhow, we have hypothalamus, pituitary gland, some textbook called hypothalamus master gland, some textbook call it, pituitary is a master gland, whatever. Pineal gland, I'm not going to say much about it, but pretty much pineal gland is responsible for your biological clock. And biological clock, if you go to Europe, right now it's night there, and then you're daytime there, so your sleeps get all mixed up until a few days, then your sleeps come back. They've done a lot of research on pineal gland forces. But then, thyroid gland, Thalamus, where is thalamus? Here we go. Thalamus right here, thyroid right here, and then a thyroid gland in the back of it. If I turn around, there are 4 parathyroid glands here. And then you have heart, of course. Then you have adrenal gland on top of your kidney. We do have slide of it. Okay, 2 of them. And then what else? Liver, of course, it can be. And then, of course, the ovary and testes, they can be both reproductive and endocrine system. Pancreas is both digestive system and endocrine system. So it can be in both. Thymus gland is both immune system and endocrine system. But for example, thyroid, no, it is just endocrine. Okay, pituitary, endocrine. Hypothalamus is both nervous. I don't know. There are debates on that. Anyway, okay. Yes, stomach releases some hormones. Okay, right here, there are 2 hormones that are stored. There are 2 hormones that are stored in your posterior pituitary gland. Oxytocin and vasopressin, or antidiuretic hormone. They call it ADH, or or vasopressin. So these 2 hormones are made in hypothalamus, and they go through a structure called infundibulum, right here, infundibulum, and they're stored in posterior pituitary gland, posterior pituitary gland. And these are the bones of your skull, right here. Is the bone. So that's the story for posterior. And of course, you know, oxytocin, it is responsible for birth, you know, during stimulus contraction and during the uterine, during the birth. But one thing that you should bear in mind in this class, that you should know, all of the hormones women release, men also release them. However, the amount varies. Okay, women also have testosterone, believe it or not. Oh, really? Testosterone in women? Yeah, they have it, but the amount is very less. In men, the amount of testosterone is large. Okay, same as oxytocin, especially during labor. A lot of oxytocin is released in women. Men have oxytocin. What is the function of it? It's up for grab. I mean, I had over the years students talk about what is the function of oxytocin in men. Yes, you know, it's not up for grab. They still talk about it. They still, people do research. But every hormone, women have, men have it too. I want to make it some sense. So oxytocin came up. Antidiuretic hormone, it works on your kidney to say, okay, we need to store the water. Do not do it. If you're stranded in desert, you're playing sports, so there is ADH release to store the water in your body. Tell the kidney store the water. Okay? But when you're drinking a lot of alcohol, it's antidiuretic. It's antidiuretic. Or caffeine. I'm sorry. Alcohol is diuretic. Sorry about that. And caffeine, tannin, these are all diuretic. It makes you to urine. Those are compounds, molecules that are diuretic. It makes you urine. Okay? But then that's a little bit of information right there. Okay. Anterior pituitary, I'm done with posterior pituitary. There's nothing else I have to say about posterior pituitary. Anterior pituitary gland, the story is a little different. There are more hormones in here. Okay, and the morning lab, the group who did this morning did a good job. But anyhow, let's go over. The growth hormone right here, growth hormone is responsible for stimulate general body growth. This hormone is in you guys, and of course in little kids. It's secreted a lot during night when you sleep. There's a peak of this hormone. The growth hormone it maintains your body. Remember, all of your cells of your body die, and all of the cells of your body regenerate. I gave you just the skin every 2 to 3 weeks, from mouth to anus every 2 to 3 days. Red blood cells, 120 days. I gave you those. Okay. So growth hormone is responsible for a lot of activities in your body, a lot of things. Then you have prolactin, of course, during the initiates milk production and plus oxytocin. They both work together after childbirth. Your ACTH, adrenocorticotropic hormone, goes on top of the adrenal glands on top of your kidney and stimulates that, makes that to do its job, which I will talk about it here in a minute. Then melanocyte stimulating hormone is responsible for coloration of your skin a little bit, pigmentation of your skin. You stay in the sun, you know, it's secreted or not. Again, when I took endocrinology in Kentucky, they said this hormone belongs to the medium lobe. You know, a lot of textbooks bypass the medium lobe. They say anterior lobe of pituitary, posterior lobe, and there's a medium, the one in between. A lot of textbooks bypass that. I don't know why. But when I took endocrinology, they said there is a medium lobe, and your textbook, I think, acknowledges it, that there is a medium lobe. And that the hormone comes from there. But in this diagram, they say, okay, MSH comes from anterior, which is fine, that's okay. But, again, I'm not holding you responsible. You're not taking endocrinology. Then you have thyroid stimulating hormone. When you go to a doctor, your thyroid is malfunctioning. One of the hormones they check is the hormone that comes from your pituitary gland. The hormone that comes from pituitary gland affects thyroid gland. The hormone that comes from pituitary gland affects your adrenal gland. Okay, those are the two hormones that we discussed so far. So it stimulates thyroid hormone, and we'll talk about thyroid hormone. Then you have two hormones, both in male and women, both men and women, follicle stimulating hormone and luteinizing hormone, and these are the effect on them. Make sure you know them. The effect of, for example, follicle stimulating hormone in male. Okay, stimulates sperm production in testes. Okay, so make sure you know those, and you have immunoglobulins. Do not worry about endothermins. Do not worry about that. That's the physiology for us. Here it is. What happens between neurons and the hypothalamus and so on and so forth.